If you want to stop encountering the same bugs over and over, you need to rethink how you're using Python exceptions. Error handling is boring, but this is the exception. So let's raise an exception. Division by 0 is not allowed, so this raises a 0 division error. Okay, so this happens in your code. What do? Is this how you handle it? Accept, pass. Nothing happens. I can rerun it. And what happens if you add this into your code? Here we say variable a is 2, and then we try to set it to 1 divided by 0, which will raise the error, but we accept it. Your variable stays 2, your error is hidden, and your code does not do what you expect it to do. Alright, back to our exception. What is the 0 division error? If we go to the Python documentation page about exceptions, at the first line it says, all exceptions must be instances of a class that derives from base exception. But what is this base exception? If we scroll down a little bit further, we will see the exception context, and that says 3 attributes on exception objects. So as in Python, everything is an object, and these exceptions are no exception. If we scroll down to the bottom, we have this exception hierarchy, and we here can see base exception as the base class. Groups of exceptions, we have the exception, which is most people use in exception to catch all of the exceptions below that one. And here we can see our 0 division error, which is actually a child of the arithmetic error, which is a child of exception, which is a child of base exception. And if you want to go deeper than that, you can look at the Python source code in the objects and then the exceptions.c, and you can find the actual C code for the exceptions. So how then should we handle these exceptions? Here we can see we can use an except to catch just the 0 division error and then print 0 division error raised. And if we run that, we will see that that is printed, and if I add some exclamation marks to it, it will be updated. So if this code in the try block triggers the 0 division error, then the part in the except class will be right. So in the last slide, we caught the 0 division error, but now we added an except class with the arithmetic error in there as well. So if you can remember the hierarchy, it goes from base exception to arithmetic error to 0 division error. So if I run this, what do you think will be printed? It prints the arithmetic error raised because that's the first exception that is caught. Because it's higher in the hierarchy, it will go into there first and then raise that. So if you were expecting 0 division to be raised, that's not what's happening in your program. So if you try to do something in this block, change the variable or whatever, then that will not happen, but your code will still continue on. So here we have one that goes a step further. We now also add the except exception, which as a lot of beginners do, because that catches every exception. And if I run it, we'll see that it only says exception raised. So what will happen if I move this block down? So now, following the Python style, it will go from the top to the bottom. So maybe it should hit the arithmetic error first. And that is indeed what happens. So there is an order to the hierarchy, but there is also an order in your Python code. If you put the except 0 division error at the top, even though your exception catches all the exceptions, it will still trigger the 0 division error raised before that. So now we learned about the hierarchy of the exceptions and in which order they are triggered. So what kind of issues can you run into this? What kind of issues can you run into with this? So here we have a function that does not exist, and if we run it, we get a name error because it's not defined, so Python can't find it. Alright, we wrap it in the try and accept, but now we accept the exception and then add the pass to it. This code just runs perfectly fine. So even though it doesn't exist, Python should fail on it. We can just continue on as if nothing is wrong, as if nothing went wrong, because we accept that exception, not the base exception, but the top layer above the name error, and thus cancelling out the name error from triggering. Important thing to keep in mind is that the hierarchy is a tree and it only travels down. So in this case, we're raising an exception and we're trying to catch it with a value error. And if I run this, we'll see that the exception is still raised even though we're trying to catch it. because general exceptions are not caught by a specific handling. So if I would raise this as a value error, then it is caught in the printed part. But because we had exception, which is the parent of this, it will not be called. Today you saw how exceptions work in Python, why a bare except is dangerous, and how to handle errors more cleanly. Getting this right makes your code safer, easier to debug, and it looks more professional. In the next video, we'll go deeper into this with custom exceptions, how to handle logging in these errors, and how to raise errors to let other developers know what's going wrong. That's where the real power of the Python exceptions comes in. Subscribe to my channel so you don't miss part 2, and leave a comment if you've seen any error handling disasters in Python.